Hello from Kazakhstan. My name is Rustam Yishpanov. I am the first author of a paper called KazNERD, Kazakh Named Entity Recognition Dataset. First of all, I would like to express gratitude on behalf of the three authors of the paper for accepting it for a poster presentation at the 13th International Conference on Language Resources and Evaluation, and thus providing us with the opportunity to represent Kazakhstan in general and academic research efforts in developing the Kazakh language in particular at this event. We represent the Institute of Smart Systems and Artificial Intelligence, ISAI for short, under Nazarbayev University. ISAI was founded in September 2019 to serve as an engine of research and innovation in Kazakhstan's digital domain with a focus on AI research. The Institute provides a flexible framework for research, innovation and collaboration with national and international partners in education, industry and government, and contributes to Kazakhstan's digital ecosystem to advance national development goals. Some of the Institute's natural language processing projects include development of Kazakh and Uzbek speech opera, as well as AI-based voice technologies, including automated Kazakh speech recognition and Kazakh text-to-speech technology. All the pre-trained models of the Institute's projects, as well as datasets developed, are free and publicly available on ISAI's GitHub page. In 2021, about 70 research assistants were hired and involved in the Institute's research work and activities. Of these, 30 were university students. ISAI strives to be a diverse community, providing opportunities for everyone, and encourages and supports women in technical ideas. Currently, 9 of the 22 ISAI team members are female. Let us get down to the article. Named entities refer to textual units not only corresponding to names of persons, locations, and organizations, but also covering numerical and temporal expressions such as dates, monetary values, and percentages, among others. Named entity recognition, or NER for short, is generally regarded as one of the building blocks for many natural language processing applications, which focuses on identifying named entities in semi-structured or unstructured texts. In this slide, you can see a list of some of the widely known NER datasets for different languages. Our dataset KazNERD is the largest annotated dataset for the named entity recognition task in Kazakh. Kazakh is a low-resource Turkic language with the earliest NER research dating back as recently as 2016. There is evidence for annotated dataset construction as part of Kazakh NER research, but none of the works provides public access to the datasets. What makes KazNERD stand out from the body of research on Kazakh NER is that the dataset is publicly and freely available for both commercial and non-commercial use. The dataset contains over 112,000 sentences from Kazakh television use that were annotated by 2 native Kazakh speakers under my supervision. As a result, a total of more than 136,000 entities were annotated. To assist the annotators in making the right choices when presented with expressions potentially matching named entities, we developed Annotation Guidelines, which are the only guidelines of their kind in and for the Kazakh language. The guidelines contain rules for annotating 25 named entity types and illustrative examples of Kazakh named entities. Finally, we built 4 state-of-the-art machine learning models to automate Kazakh NER, with the highest exact match of 1 score reaching 97.22% on the test set. As I have mentioned earlier, the dataset guidelines and codes used to train the models are freely available for download under the CC BY4 license from the Institute's GitHub repository. As regards the named entity recognition task for Kazakh, only relatively latterly has the language appeared on the radar of NER researchers. At the time of conducting our research, there were only 6 related studies that we were able to find. The comparative table illustrates the studies, with our study highlighted in green at the bottom of the table. In general, the majority of Kazakh NER studies did not provide clear breakdown of the annotated named entities. Hardly ever did they mention the annotation guidelines used for the task, nor did they provide information on the inter-annotator agreement assessment or how the resulting annotated datasets could be accessed. Our motivation for building an annotated dataset, annotation guidelines, and models to solve the Kazakh named entity recognition task derived from an urge to address the lack of free, publicly available Kazakh annotated datasets, as well as guidelines that could be used to assist in annotation. We also pursued the goal of providing clear explanations for the general public of each step we took in carrying out such a task. Let us move on to KazNERD development. We obtained the source data containing television news from a major broadcasting network in Kazakhstan. The transcribed text accompanying the original news included reports on events in local and international politics, economy, sports, religion, and education. The text was split sentence-wise, with an identifier assigned to each sentence. We inspected the text for grammatical and spelling errors as well as homoglyphs. Duplicate sentences and those containing only Russian utterances were removed. Since Kazakh-Russian code switching is normal practice in Kazakhstan, sentences containing both Kazakh and Russian utterances were retained. The total number of sentences was just over 86,000. To enable the four named entity recognition models to recognize instances of the same named entity regardless of their typographic characteristics, for example numerals written in words versus numerals written in digits, we adopted 6 sentence representation variants. The resulting number of sentences in the 6 representations was equal to more than 112,000. We chose the IOB2, also known as bio scheme, for annotation. Under this scheme, each token in text receives one of 3 tags, B, I, or O. If a token is at the beginning of an annotated extent, it receives a B tag. If it is inside of the extent, then an I tag. If a token is outside of the annotated extent, then it is tagged with O. Because there had been no annotation guidelines for Kazakh named entity recognition, it was decided that we should create our own set of rules. To this end, we studied some of the most referenced guidelines. Then, I experimentally annotated a random sample of 2,000 sentences to gain an understanding of what named entities could actually be extracted from the data at our disposal. 22 named entities described in the oft-referenced guidelines were found in the sample. The first draft of guidelines in Kazakh was prepared. It contained the definition of a named entity, information on the valid boundaries of named entities, rules for named entity classification, and illustrative examples. Later, while annotators were receiving training in named entity tagging, we decided to tag another 3 named entities which were present in the news reports, namely non-human, miscellaneous, and adage. While non-human and miscellaneous had been previously mentioned in the oft-referenced guidelines for named entity recognition, our motivation to tag a class called adage derived from the relatively frequent use of Kazakh proverbs and sayings in the sentences that the annotators labeled as part of the training. We made due adjustments to the guidelines, clarified some rules, and provided more comprehensible examples. It should also be noted that as annotation proceeded, the guidelines were iteratively amended to embrace cases that were not taken into account while drafting the guidelines. We also daily addressed the annotators' questions as well as some challenging and confusing cases. The final version of the guidelines contained rules for and examples of 25 named entity types. We tried our hardest to make the guidelines user-friendly and provided our contact information for users who might have comments or suggestions about possible improvements to the guidelines. The guidelines were last updated on the 25th of April 2022. 2 native Kazakh-speaking linguists received training in named entity recognition for 2 weeks under my supervision. 3,500 sentences from the source data were annotated using the guidelines developed. Annotation was carried out using the Webano web-based tool. The 2 annotators worked independently on the same text file, which I later reviewed for divergences and inconsistencies in annotation. The reviewed version of the text file contained annotations that were approved or modified as appropriate. The inter-annotator agreement was 0.94 flies kappa, which was computed by Webano. Overall, the annotation process proceeded for 6 months with 1,500 sentences annotated per day. During the period, the inter-annotator agreement score was in the range of 0.95 to 0.97 flies kappa. The resulting annotated KazNERD contains 136,333 named entities. As you can see from the table, the top 3 named entities in the dataset are cardinal, date, and geopolitical entities. It should be noted that none of the previous Kazakh NER studies has labeled the classes cardinal and date. The bottom 3 named entities are contact, adage, and non-human. Surprisingly, the class adage, which was labeled out of scholarly interest, numbered 196 entities in total, being higher or comparable in size to the classes previously described as relatively frequent in the named entity recognition literature, such as miscellaneous, contact, non-human. The class miscellaneous embraces names of school and university subjects, types of computer networks and technologies, livestock, breeds, or entities that we struggle to categorize or deem superfluous to label as separate classes. What is indeed remarkable is the use of numbers in the dataset. The 2 classes denoting numbers, cardinal and ordinal, comprise practically a quarter of the total quantity of named entities in the dataset, a hefty 24.3%. To allow for reproducibility of the named entity recognition experiment between different research groups, we divided KazNERD into training, validation, and test sets. We further extracted all unique named entities from the dataset. The sets were stored in separate files in the Connell 2002 format, that is, all files contain one token and the corresponding IOB2 tag per line, with blank new lines representing sentence boundaries. To allow for more nuanced studies requiring representation level and sentence level detail, we also provide variants of the files containing identifiers heading each sentence. Sentence identifiers are representation designations followed by a unique 6-digit sentence number. In the table, you can see the distribution of sentence representations across the training, validation, and test sets of KazNERD. To evaluate KazNERD, several state-of-the-art machine learning methods were applied. Specifically, we applied a conditional random fields model, a BILSTM CNN CRF model, a BERT model, and an XLM Roberta model. All the 4 models were trained on the training set, with the hyperparameters tuned on the validation set. We evaluated the final best-performing model on the test set. The deep learning-based models were run on a single V100 GPU on an NVIDIA DGX2 machine. In the slide, you can see all the parameters set for the 4 models. We evaluated named entity recognition performance in terms of exact match using precision, recall, and F1 score, and the standard seq-eval script requiring that both the type and span of predicted named entities match the gold standard mention. In the table on the left-hand side, you can see the performance of the models on the validation and test sets of KazNERD, measured with micro-averaging. The highest results were achieved by XLM Roberta. Overall, all the 4 models produced a good performance, achieving precision, recall, and F1 scores of above 90%, which highlights the utility of the dataset for the Kazakh named entity recognition task. In the table on the right-hand side are the results of the XLM Roberta model for the 25 named entities. The performance of XML Roberta was 95% for 14 named entity classes, in the range of 85% to 95% for 8 classes, and below 85% for only 3 classes. The model yielded almost perfect results for the classes money and person, which we believe could be accounted for their composition. Because the extent of money named entities includes a monetary value and an explicit monetary unit, this must have made it easier for the model to recognize the class. Similarly, in the Kazakh language, person named entities often appear as a combination of first and last names, both capitalized and the latter normally ending in specific affixes. We presume these features enable the model to achieve high prediction accuracy for the class. The low F1 scores for the classes non-human and adage are likely due to the apparent insufficiency of instances of the non-human class and the form variability of proverbs and sayings under the class of adage. We expect that by increasing the number of non-human named entities in the training sample and expanding the dataset to embrace domains in which the use of names of non-humans is common, the accuracy of the model will improve. Adage named entities, which if you remember we labeled out of our pure scientific curiosity, might have been difficult for the model to recognize because of lexical and grammatical variations that a given proverb or saying can have. The model might have failed to decide whether a given expression is a pre-existent variation of a known adage, its nonce restructuring, or not an adage at all. This may particularly happen if there are not enough data to make inferences from. Since the present study was the first to develop a publicly available annotated dataset, as well as guidelines in Kazakh for 25 named entity classes, it was subject to several challenges. The first challenge concerned named entities that are capitalized in English but normally lowercased in Kazakh, which took us longer than expected when manually annotating sentences. Another 2 challenges concerned coordinated and nested named entities. We decided to label coordinated and nested named entities as a single entity in accordance with the recommendations of Mach 7, which promoted joint annotation. As regards challenges related to metonymy, in line with the Mach recommendations, we generally retain the semantics of common named entities in our dataset unless we specified a certain rule in the guidelines. Lastly, as for challenges presented by the ambiguity between some named entity classes, in the guidelines we provide instructions on preferences given to tagging such entities in cases of confusion. In conclusion, I would like to repeat that the annotated dataset, guidelines, and codes used in training the models can be freely downloaded under the CC BY4 license from GitHub. In the future, we aim to focus on developing fine-grained and domain-independent NER models to ensure their external validity. To this end, we intend to train the models on a version of KazNERD supplemented with annotated data from different domains and genres, including transcribed conversations from television and radio shows, podcasts, phone talks, fiction, and parliament speech. Here is a list of the references made in the presentation, and this is the end of the presentation. We would like to thank you again for having us at the 13th International Conference on Language Resources and Evaluation. I wish everyone watching this video every success in any endeavor you make. Goodbye.